Assalamu alaikum. My name is Muhammad Al-Suwaidi, PhD student at the University of Liverpool School of Architecture. I'm very excited to be able to take part in the ASCAAD 2022 conference, Hybrid Spaces of the Metaverse. The topic of our research is titled The Application of Immersive Technologies in the Early Design Stage in Architecture Education, a Systematic Review. The authors of this paper include myself, Asterios Agathides, Adonis Haidar, and Davide Lombardi. The aforementioned authors are also supervising my ongoing research at the University of Liverpool School of Architecture. The research conducted is an initial step towards our exploration and thorough research in developing and exploring the potential implementation of immersive tools in education and practice. As a systematic review paper, we focused on the filtration of existing research that involved the use of virtual reality, architectural education, and potential use of software similar to Graphity Sketch, Unity within the virtual environment sector. The filtration of existing research is based on relevant approaches that investigate the use of creative thinking, teaching methodology, and the use of immersive tools. As one of the findings of this paper, we explore the evolution of immersive tools in addition to understanding the advantages and disadvantages of immersive tools throughout the design process and also the implementation in practice. Further findings also lead to proposing a novel teaching methodology that incorporates the use of these tools in the early design stages and design phases of architectural education. One of the main factors that we look into in this research is accessibility and the evolution of these tools. Looking at how these tools can allow the user to grasp a one-to-one scale of the space itself that has been designed and also be able to walk through these areas and further analyze the space from a visualization perspective. As an extension to this, we look into how VR and VE tools can further be elaborated to not only be representation tools, but also begin to allow the user to test out various interactive techniques like 3D sketching and collaborative design methods in the VR and VE environment. By investigating this approach, we look into our main initial research questions, which include the following. How can we develop an educational framework incorporating virtual environments into the early stages of design process in architectural education? And what existing software and hardware can be utilized to achieve, develop, and test this framework practically? As an initial step to our research, we have been able to include the following phases that included the filtration, article search through databases including Scopus and CubanCAD, screening these selected papers and comparatively analyzing and categorizing each paper and its design methodology approach. Later on, we evaluate each software and methodology approach that has been used in each of these papers through charts and tables, in addition to understanding how and why these tools were used. After filtering down these papers, we then place them in a timeline order to understand the initial approach and how these tools were used back then in the 90s, all the way down to the present time. The VEL lab, also known as the Virtual Environments Laboratory, was one of the initial steps towards incorporating the use of virtual environments in the student cohort and educational platform. The VEL lab explored the use of a panoramic screen that displays a wide field of view. The display itself was located in a physical room that hosted up to 14 students per session, in addition to allowing the one main user to present a series of pre-built projects to the students via the medium itself. From this paper, we begin to understand that VE tools have always been explored back in the past, looking at how these tools have also advanced today with the software and hardware implementation of VR and AR tools. We begin to understand that these tools have become a lot more accessible and also offer a lot more capability to assist and aid the design process as well. Virtual reality was initially limited in graphical power and visualization in early 2000s. Voxel design was an innovative approach that accommodated this limitation. By utilizing a building block scheme that provided the user with the ability to create sculptural and structural forms in 3D blank space in VR. This was done by stacking and coloring a number of cubes to create different compositions and explore different ways of creation. DD Duels was the name of the software. It was developed in Bauhaus Universität in Weimar with a primary incentive to achieve a simple user interface that supported easy creation in VR environments, in addition to allowing supported easy navigation and manipulation in the VR environment to support spatial understanding of the design at one-to-one scale. Modern tools, like Google Tilt Brush, took a very similar approach to DD Duals, but instead of being limited to the voxel design, users were able to draw in freeform using varied textured brushes and also create different compositions and explore them in different techniques. This approach was implemented in a study that takes a very unique theoretical and practical approach to the architectural design process by involving performative gestures that were then recorded using VR and later explored in architectural format. Software like Google Tilt Brush, used by Barzik, falls under the digital sculpting category, enabling the user to sketch in 3D space. Other software like Google Blocks and Gravity Sketch follow a very similar framework to Google Tilt Brush, with similar user demographic and mind for each platform. This is made clear when highlighting the toolset and export options that each software offers. Now, the research was executed by enabling live model interaction within the process of creation while considering the possibility of implementing the idea of direct design. For this process, Google Blocks was utilized, allowing the user to create simple compositions in 3D space in the VR platform. The main limitation of the software is primarily the lack of design tools that enable the user to scale and modify faces in the model to achieve higher details in their 3D models and sketches. More advanced software, like Gravity Sketch, become just as accessible, yet offer a lot more toolsets that allow the user to create more complex structures and designs. This then leads us to understanding further approaches in interactive design through utilizing game engines to create interactive design and immersive assessment. Game engine software has evolved with the intention to appeal to various platforms, including architectural and visualization professions. Game engines like Unity and also Unreal Engine follow a very similar UI design language to 3D design softwares like Autodesk 3ds Max and Maya. This UI similarity allows the user to increase the adoption of the platform due to its familiar UI design. We begin to understand that the approach of implementing immersive tools is an ongoing process. We highlight a series of different projects, which include different approaches to the design methodology, in addition to understanding how they were able to incorporate the software and introduce it to a series of users. Some of these projects were conducted in an academic and educational platform, whilst others were conducted in a public space. Projects like the VEL Lab were one of the initial approaches to incorporating immersive tools as part of the design process. We then delve into the interactive aspect of digital design. DD Duals was later used to explore the concept of voxel sketching in VR. Even though voxel design was initially used because of the graphical limitations given at the time, Minecraft is a modern video game that embraces voxel design. Due to its simple visual, the modern video game software welcomes a large number of contributors due to the platform's popularity in a recent study conducted by Delaney. The project resulted in a very positive outcome when it came down to addressing inclusive, collaborative, and interactive design. Because of the accessible nature of voxel design, users were no longer overwhelmed by complexity that is limited by detail, and it allowed them to also use more of their imagination to explore and create different compositions that can then be further adapted into more complex structures and designs. This is when the utilization of game engines can take place. Projects that incorporated the use of media stage and Unity as part of the design process enabled the students to develop immersive experiences that involve interactive input systems that can be used for spatial analysis and visualization. A recent study utilized the use of game engines alongside the use of Rhinoceros and Grasshopper plugins to explore AR methods that enable the user to translate and modify their 3D parametric models to fit in specific locations through an AR lens. VR and VE tools can lead to unique results that can vary based on the adopted software and design brief. This paper aims to utilize software that is accessible and offers a set of advanced tools that can lead to more complex results. Consequently, the software must also offer multiple export options and enable multi-user support for potential collaborative design. Based on the analyzed paper, most of the software used showcase some limitations including the design toolset, accessibility, and ability to export the model for further development. Little to no research has been done using Gravity Sketch. Even though the software showcases great accessible potential to be used as a sketching, modeling, and refinement tool throughout the architectural process, Gravity Sketch is a recent tool released in 2017. housing a number of design tools like 3D Sketch, Edge Grab, Massing, Surface, Scale, and Materiality, and others. As an extension to this, Gravity Sketch also enables model import and export in various formats that enable external software compatibility. Site models, in this matter, can also be imported to scale to allow the user to sketch at one-to-one scale and explore different form-finding techniques in this process. The Unity game engine can then be utilized to assess the model and further elaborate and develop the design. In conclusion, throughout the filtered papers, only 4 papers have attempted to integrate VR and AR tool as a substantial part of the design methodology. Substantial use is defined by the level of VR and AR technology utilization throughout the different stages of the architectural design process. Instead of limiting the tool for visualization purposes only, each of these papers utilize VR and AR using different techniques, some of which enable the student to sketch, explore, alter, and assess their design throughout the different stages of the project. Others showcase the remote potential for collaborative design and assessment for techniques between peers and the lecturer. Finally, having analyzed the different pedagogic approaches and the integration of VR and AR technologies into the design process, we propose a novel design and teaching framework enriching the generative design methodology proposed by Agathidis by integrating VR and VE tools and exploring contextual-based problem-solving techniques similar to the research done by Delaney in 2022. Throughout the design and interactive process, the design workflow can cycle through multiple iterative stages, allowing the user to refine their designs throughout their project. The proposed framework is an output of the review that has been conducted. The framework itself will be tested and evaluated in Design Studio classes in our future work that aims to provide a conventional methodology for immersive architectural design. This concludes our presentation. Thank you very much for listening. Assalamu alaikum.